All right, now we're going to look at an example in context. So a phone tree, just something that is a little outdated. But for instance, this is how when I was in school, we found out about um, snow days or asynchronous days or what have you, where one person would make a call to a certain amount of people, and then each of those people would make a call to a certain amount of people until everyone got the message. So you can see how it's kind of like looks like a tree. So we're going to write an explicit definition to find the number of people called in each round. What we know here is that um, in the fifth round, 243 people were called. In the first round, 3 people were called. So we're going to start by writing a general explicit formula. So a sub n is equal to a sub 1 times r raised to the n minus 1. 243 is the amount of people called in the fifth round. 3 is the amount of people called in the first round. So that's your formula there. Now we're going to try to isolate the power by dividing by 3. So you get 81. And then you end up with 81 is equal to r to the fourth because it's the fifth round. So n minus 1 would be 4, which then makes r equal to 3. So your common ratio is 3. So the explicit definition is a sub n is equal to 3. The first 3 represents a sub 1. The second 3 represents r, and then raise to the power of n minus 1. In part B of the example, we want to find out how many people were called in the eighth round. So we're going to substitute 8 in for n, and then solve. So you get 6,561 people called in the eighth round. All right. So we're going to look at this example here. So pause it, give it a try, and then come back and check your answer. So we start with the general form of the explicit definition. We know that on the 10th day, there's 3 to the 20th. On the first day, there's 9, right? And then since the 10th day, the exponent would be 9. We're going to isolate the power first by dividing both sides by 9. Since 9 is 3 squared, 20 minus 2 is 18. So it's 3 to the 18th. So you get 3 to the 18th is equal to r to the 9th. You can just take the 9th root of both sides. Another way to do it by hand is to consider you can rewrite 3 to the 18th as 3 squared raised to the power of 9. Since you got both exponents of 9, that means r must equal 3 squared or 9. So now the first term is 9. The common ratio is 9, meaning it multiplies by 9 every day. So the 7th day in the sequence is going to have an exponent of 6. So 9 times 9 to the power of 6 is 4,782,969. So a bacteria, that's how it works. Bacteria spreads by, an exponential model. So, okay, let's look at example 4.